This video is about rational exponents, and I guess I should break down what those words mean, rational exponents. Okay? Because most times when we think of exponents, we think of x squared or x cubed. And those are definitely exponents. I'm not trying to refute that. But there's some times in math where exponents can get a little confusing. We could write something like x to the 3/2 power. Okay? So these exponents become a little bit more complex. And when you think of the word rational, hopefully in mathematics you were taught that fractions are rational numbers. Because what fractions are numbers that could be so you could change a decimal like 0.75, right? And 0.75 is really 75 over 100, right? Because 75 divided by 100 is 0.75. But you can reduce that fraction 75 over 100 all the way down to 3/4, right? So in this case, if I had 1.5, okay, 1.5 is a terminating decimal that ends, and therefore it could be quantified as a fraction, which is 3/2. So rational numbers are numbers that either have a ending decimal, like it's 0.75 or 1.5, or have a repeating pattern in which can be quantified as a fraction. Irrational numbers, such as imaginary numbers or pi or Euler's number, again, those are decimals that continue on forever and ever without any particular pattern, so we cannot write them as a rational exponent. Okay? So, an exponent, of course, are another kind of name for that would be the powers. So the power that is raised to, kind of like x to the 3rd power. All right? But implying that they're fraction powers, okay, we have to define what each part means. So the top number, and if you really think about it, that represents the power, meaning it's still x to the 3rd power, okay? But the number on the bottom, what that refers to is the root, okay? Because when we're talking about exponents, and when something is, like let's say we had just x squared, okay? Let's say we had x squared. And for x squared, what is the inverse or the opposite of squaring something? It's the square root, right? That's how we get rid of a square. And now we don't call it that, but so let's take a look at x to the 5th. So when I have something to the 5th power, the way I get rid of it is by taking the 5th root, okay? And so powers and roots are inverses of each other. So they're similar operations, but they're just the opposite, right? So kind of like 3/2, instead of multiplying by 2, I'm dividing by 2. So instead of multiplying 3 by 2, I'm dividing by 2. So multiplication and division are inverses, addition and subtraction are inverses, powers and roots are inverses of each other. Okay? So for this problem, what you need to do is rewrite it as a radical expression. Okay? So meaning I still have, so that bottom number 2 goes on the outside of my root, and then it's all raised to the 3rd power. Okay? So it's square root of x all to the 3rd power is how you'd write this, and this is called radical form. Radical form. Okay? And this right here is called exponential form. Okay, so you have to know how to go in between both of them, and there's benefits to both, and obviously based on the information that we need to find or the information we have, we can use either form. But for today and our purposes for tonight's homework, all you need to do is know how to go back and forth in between the two. Okay, so if I have 10r to the 3/5 power, I can rewrite that, because remember 3 is the power and 5 is the root. Okay, so I'm going to take the 5th root of 10r, and it's all to the 3rd power. Okay, so I mean it really is that simple. It doesn't matter if there's a number in there, because notice how it's all in parentheses, right? So it's 10r, all of that is to the 3/5 power. The bottom number is the root, that goes on the outside of the radical, and then 3 is the power, so it goes at the top in parentheses. So 7m to the -4/3 power, this is where it gets a little more fun. Okay, so I obviously know 7m goes inside the radical. I'm going to put a 3 on the outside because that's on the bottom. That's my root. Okay, and now the 4 goes on the outside. But notice how there's a negative involved, right? Always keep the negative with the power, because we've learned and we've talked about how we deal with negative exponents or negative powers. We've never had to deal with a negative root. It's possible, but it's a lot more sticky and messy. So we'd rather deal with negative exponents and learn how to change those. Okay? So in this case, how do I get rid of a negative exponent? Well, I still have to put the invisible one down below. And all of this is to a negative exponent, so it needs to move down to the bottom. So it would be 1 over radical 3 of 7m all to the positive 4th power. Because I can't have negative exponents, so that would be the positive exponent. So rewrite it and then put the positive exponent. All right, and of course, if we can go from exponential form to radical form, we can go the other way. So now I have it in radical form, I need to go to exponential form. Okay, so 6 is my root, 5 is my power, and m is obviously the base, so it's m to the 5/6 power, right? Because the root goes on bottom, power goes on top. Because obviously if you're more powerful, you go on top. All right, and then this one, okay, so 5 is my power. Oh wait, where's the root? There's no number here. What? Where is it? Now, normally in math, we would say, oh, if there's nothing there, we assume there's an invisible 1. Let's think about this for a second. Think about another situation where we have a radical, but there's no number on the outside. This is what we call a square root. So instead of there being an invisible 1, there's actually an invisible 2 on the outside. And that's where square roots come from in the first place, right? So there's an invisible 2 on the outside of there, and that's my root. So it's going to be n to the 5/2 power. Okay. And then there's always a question that comes up, and I'll go ahead and answer it right here. Mr. Schwann, what if I have something like this? 3rd root of x to the 6th power. And you're saying, okay, let's go ahead and change that to x to the 6/3 power. If you can reduce the exponent or the rational exponent or the fraction, do that. That's fine. Because I can write x squared. And doesn't x squared look a lot nicer than cube root of x all to the 6th power? Okay? But a lot of students get confused. Well, wait, wouldn't that change the problem? Well, no, because if I'm taking the 6th power and then taking the 3rd root of that 6th power, remember they're inverses of each other, and I'd just be left with 2. So if you can reduce the rational exponent, you can go ahead and do that. So just know how to switch in between both exponential form and radical form, and then reducing as necessary.